Quality check passed. Proceed to packaging.
In this video, I'm going to be talking about iron trapped in macrophages. If that happens, the tumors, they can actually receive or get the iron from the macrophages, and tumors upregulate a transporter to be able to receive the iron from the macrophages. Now, the way the iron gets trapped in the first place could be due to a copper deficiency, possibly from excessive zinc, because if the zinc is too high, then the copper will be too low. Therefore, the iron is not properly metabolized because the ferroportin is less or deficient or downregulated as a result of copper deficiency, because copper is responsible for the ferroportin exporter. So basically, ferroportin is responsible for exporting iron away or out of macrophages. So as a result of copper deficiency, the iron becomes trapped in the macrophages. As a result of this, even an iron deficiency ends up as the result. Therefore, red blood cells, they don't get the iron. Um, Therefore, tissues are hypoxic or low iron because the red blood cells could not deliver oxygen around the body. Uh, Also, what could worsen this whole process is glycation end products, also rigid ECM, or the extracellular matrix, meaning immune cells cannot enter to battle cancer cells. That is because of the iron deficiency, leading to vitamin B12 deficiency, because vitamin B12 is supposed to upregulate glutathione, and so that glutathione reduces advanced glycation end products. So this all links back to the copper deficiency because of the excessive zinc. So excessive zinc is leading down this downstream domino effect of eventually leading to an iron deficiency because of the copper deficiency. Okay, M2 phenotype macrophages also play a role here. So M2 phenotype, it's the tumor-supportive phenotype. So the opposite would be an M1 phenotype, which attacks tumors. M1 phenotype kills tumors. But tumors, they have the ability to change macrophages into the M2 phenotype. So the M2 phenotype promotes tissue repair and supports angiogenesis, which is a VEGF, the blood vessel growth, or the tumor uses existing blood vessels to grow. That's why they change M1 macrophages to M2 macrophages. Also, the one of the main pathways involved here is the STAT3, STAT3. Okay, so ferroportin is responsible for exporting or taking iron out of the macrophages. uh, what actually reduces or downregulates or degrades their ferroportin is the STAT3 pathway. Okay, so hepcidin also binds ferroportin and then triggers its degradation, preventing the iron export out of the macrophages. So possibly IL-6 production by tumors um, increases local hepcidin, and also other inflammatory cytokines also elevate hepcidin, therefore binding ferroportin. Okay, now I'm going to go through a list of foods, mostly fruits, uh, to help mitigate some of the issues with iron trapped in macrophages, maybe even try to prevent it in the first place. So the first one is oranges, has vitamin C. The vitamin C enhances iron absorption, may even increase plasma iron availability, since plasma iron, it does go down when iron is trapped in macrophages or the macrophages is hoarding the iron. Next one here is pretty good, and that is grapes. Grapes inhibits STAT3. STAT3 actually inhibits or degrades the ferroportin. So grapes actually helps, or at least increases the chances of macrophages exporting the iron. Therefore, there is less iron trapped in macrophages because grapes inhibits STAT3. Therefore, STAT3 cannot inhibit ferroportin. Okay, another great thing about grapes is that it has resveratrol. Resveratrol helps the lysosomal membrane uh, to help repair it so that it is not peroxidized. So to put out the fire, which is the reason that the lysosome membrane is peroxidized in the first place. Now, the lysosome membrane can't be peroxidized because if it is, then the iron will actually escape into the cytosol, or the iron will leak out and will not be properly metabolized, therefore leading to iron trapped in macrophages. So that's how resveratrol in grapes helps out with uh, making sure that iron is not trapped in macrophages. So grapes also reduce NFKB. NFKB happens to upregulate hepcidin, and hepcidin degrades ferroportin. Ferroportin is supposed to export iron out of the macrophages, but grapes helps ferroportin by reducing NFKB so that NFKB cannot make hepcidin. Next one here is pretty good, and that is apples. Apples reduce IL-6. Therefore, IL-6 cannot make hepcidin because IL-6 is responsible for making hepcidin. Hepcidin will degrade ferroportin, therefore iron cannot be exported out of macrophages because ferroportin is responsible to export iron out of macrophages. So apples reduces the chances of hepcidin degrading ferroportin. So apples support ferroportin. Next one here is mangoes, has mangaferin, which is a compound in mango, and mangoes inhibit NFKB. Therefore, NFKB cannot degrade ferroportin. So mangoes, just like apples, also helps iron being exported out of macrophages because mangoes help preserve the ferroportin since the NFKB won't degrade the ferroportin. Next one here is pretty good as well, and that is tomato and lycopene. In tomatoes suppress STAT3, which is good, so that STAT3 cannot increase IL-6 because IL-6 is responsible for making hepcidin, and hepcidin degrades ferroportin. So tomatoes helps preserve ferroportin. Tomatoes also do something else on the RAGE receptor on the macrophages. Uh, that is so that advanced glycation end products cannot bind onto the RAGE receptor on the macrophage. So quick recap, if iron gets trapped in macrophages, the tumors have the ability to get the iron out of the macrophages because tumors need macrophages for to make their own DNA. Ferroportin degrades exports iron out of the macrophages. That way tumors cannot get the iron. Okay, oranges has vitamin C, helps absorb iron. Grapes inhibits STAT3 and NFKB, therefore supporting ferroportin. Resveratrol helps support lysosomal membrane peroxidation repair so that the iron is properly metabolized. Apples reduces IL-6, therefore hepcidin cannot degrade ferroportin. Mangoes inhibit NFKB, therefore supporting ferroportin, and tomatoes also support ferroportin. Also, tomatoes helps reduce advanced glycation end products on the RAGE receptor of the macrophages. So that's it for the video. If you want more future videos, like, share, comment. Keep it locked in here on my channel, and I'll see you next time.